Hello everyone, thanks for joining today. Okay, so today we are going to talk about how to build modern and smart search, but without needing to leave MongoDB. We are also going to go deep into MongoDB Atlas Search and see how it works under the hood. First, let's understand why search matters for modern applications. So today, almost all applications want to have a search feature, and if you don't provide it, it's like you are not providing a way where user can quickly type the text and get the result what they are looking for. In this way, user have to just navigate the pages like directory structure, clicking on page by page. In in some cases, users just leave the applications because the experience is not good enough for them. That is why search with better experience matters for modern applications, and that we can achieve using search engines. Let's understand why we need to have additional search engines, why we cannot use regular MongoDB queries. So actually MongoDB regular queries uses B-tree indexes. That is perfect for exact match, sorting and ranges, but it has no concept to provide the ability to search the text inside the sentence, handle the typos, or provide the suggestions. And that is exactly what user expect today. And that's why we need to have additional search engines like Elasticsearch or Solar. And these search engines built top of the Apache top of the library provided by Apache Lucene. Let's understand why Atlas Search. So there are already some popular search engines are available. Then why we need to have a search engines like Elasticsearch or Solar? So let's suppose if you are using a MongoDB and you need to have an Elasticsearch. So for Elasticsearch, you need to have a separate cluster. You need to copy all your data at Elasticsearch side. And you need to sync the data between your database and Elasticsearch. And that's why you need to have a pipelines as well. So at the end, you need to have a separate cluster to manage security monitoring and everything. If we use Elasticsearch, or sorry, if we use MongoDB Atlas Search, we don't need to have this additional cluster or pipelines. Let's understand what is Atlas Search. So Atlas Search is a full text search engine that lives right inside MongoDB Atlas. That provide the ability to search the text through the entire body of the sentence. As this lives right inside of MongoDB Atlas, we don't need to have separate cluster or separate infrastructure. This is powered by Apache Lucene. Use the same approach what another search engines used, like inverted index. And that is why we don't need to compromise with any features. MongoDB Atlas Search itself keep the search index in sync with our live data. That is why we don't need to have additional pipelines. Let's understand why we don't need to have a separate cluster if we use MongoDB Atlas Search. So you can see here, this is our MongoDB Atlas cluster. Inside the MongoDB cluster, we can see two processes. First one is the database engine and another one is the search engine. So database engine is used to store our data, and search engine we use to have search features. As search engines lives right alongside of database engine, we don't need to have a separate cluster. And these search engines use the same data what is stored in our database. We don't need to have a additional pipelines. Let's understand some building blocks for MongoDB Atlas Search. The first thing is search index. So to use MongoDB Atlas Search, the first thing we need to do is creating search indexes. When we create search indexes, we tell MongoDB Atlas what fields we want to make searchable. As soon the index is created, MongoDB Atlas take the definition of search index and create the inverted index. That is the actual structure that makes this kind of search faster. There are two ways to create the search indexes. First is dynamic mapping and another one is static mapping. If we use dynamic mapping to create the search index, it creates indexes for every field automatically, every field in your collection. As this is the fastest way to create the search index, we suggest it used for the demos or test environment, but we don't suggest is to use on real application. The reason is, as it create indexes for every field, it takes more spaces into the memory. The another way is static mapping. If we use static mapping to create search index, it create index for every. We need to specify the field what we want to make searchable. As this will create the index for a specific field, it will not definitely it will take less space in the memory as compared to dynamic mapping. So this is recommended for real applications. So to perform the search, first we need to create the search index on our collection, and then we can perform the search queries. Let's see how let's see search index in real action. So this is my collection called products, and currently I'm using MongoDB Compass. We can use Atlas UI as well. So we need to select our collection, then we can go on the index tab, then search index, then click on the create and search index. We need to provide the index name like test index. We need to select the mapping type like dynamic field mapping or static field mapping. We can select dynamic mapping now and then click on the create search index. As soon the status will turn into the pending to ready, our index is ready to use. So some search index I have already created, which I will use for our demo. So you can see here. So to perform the search, we need to have aggregation pipelines, and inside the aggregation pipelines, we need to have a search stage. So inside the search stage, first we need to provide the index name what we have created for this collection. Then inside the text, or we can say this is the operator called text to search the text inside the document. Against the query, we need to provide the text what we want to search, and against the part, we need to provide the column name or field name of our collection in which we want to perform the search. So you can see here, we got the search result. The same way what we have created search index using the dynamic mapping, we can create index static mapping as well. The same approach we will follow: create search index, provide the name, and select the field type, that is static field mapping. As I already explained, if we create the search index using the static mapping, we need to specify the field name. We can specify multiple fields name at once, but for now we will just create this static mapping with one field. Now our index is ready to use. Same is dynamic mapping, I can use static mapping as well, and you can see here our search is working fine. I want to show you one more things that is called analyzer. So one more thing we need to define while we are creating a search index is analyzer. So you can see here I have defined the analyzer, and against the analyzer I have defined Lucene English. Let's understand it ahead. Okay, so let's understand about the analyzer. So analyzer decide how to split the text into searchable tokens or searchable words. So analyzer split the text on spaces and create the search tokens. These search tokens are used by inverted index. These are some types of search index. These are some types of analyzer. First one is the standard analyzer, second one is the language analyzer, and third one is the custom analyzer. Standard analyzer is the default one. Default in the sense you would have mind when we created search index using dynamic mapping, we have not mentioned any analyzer. So if we don't specify or mention any analyzer, the MongoDB Atlas picked up standard analyzer. Standard analyzer split the text on the spaces and convert into the lower cases. The second thing is language analyzer. Language analyzers do everything what standard analyzer does. In addition, it understands the specific language. Understand the specific language means it is capable to make the difference between related words like run, running, and ran are related words. The third one is custom analyzer. So custom analyzer we build for special cases. Custom analyzer is the analyzer we make by our own instead of using default or ready-made analyzer like standard analyzer or language analyzers. So let's see analyzer in actions. This is our aggregation pipelines. Let me make it dynamic. Okay. So you can see here I am getting the result for running. Let's see what will happen if I will make it run. Let me convert into related words. So you can see we don't have any search result. The reason is we are using standard analyzer here. Okay. So let me change dynamic to static index where we have used language analyzer. You can see here as soon we change index name, we are able to get the result with run as well, because for this mapping we have specified language analyzer that is capable to search, perform the search using relevant text as well. Let's see about the third analyzer, that is called custom analyzer. So inside the search index definition we can define our custom analyzer. So inside the analyzers we can create a custom analyzer. We need to provide the custom analyzer name. Then we need to specify actions for 3 stages. So every analyzer has a 3 different stages that runs in sequence. The first one is the character care filters. In this action, analyzer improve the, or we can say clean up the text. For example, if you want to remove the HTML text from your data before split into searchable tokens, so we can specify the action here. The second is tokenizer. In this stage, analyzer split the text into the searchable tokens. And the third one is tokens filters. In this stage, we can specify the action to convert our searchable tokens into the lowercase. So for the special cases, we can use custom analyzers. Let's understand how analyzer works under the hood. So this is our data. In the center, we have analyzer, and the right side, we have tokens. So analyzer pick the data and split the data into the split the data based on the specific species, or we can say based on the specified type of the analyzer, is split the text into the searchable tokens. So we have here the data like running shoes. Analyzer is splitted this text into two searchable tokens like running, and the second one is shoes. Once these tokens are available, MongoDB Atlas take these tokens and store these tokens, create using these tokens, create the inverted index and store these tokens into the index tables. You can see here the these tokens have been stored into one column, and in the next column the relevant document IDs, or we can say the matched document IDs, are stored. Let's understand how inverted index makes this kind of search faster. So we are comparing inverted index with the regular index. So this is how regular index store the data in index table. So in left side of column, it has stored the data running jacket, and in the next column it has stored document ID. So to find the running inside the inverted index, MongoDB has to scan every row one by one, and then it will return the document. Whereas in inverted index, MongoDB Atlas stores all the searchable tokens, and in the next column or against the tokens, it stores document IDs in which these tokens exist. So to find the running, Atlas looks it up once and instantly returns the document IDs which contains these search tokens. So that is the actual structure. This makes this kind of search faster. Let's see some search strategies what we will use inside the MongoDB Atlas search. So the first one is the search. The search stage we use to get the matching documents. Search stage returns the relevance score with every result, and this is the first stage we need to use in our aggregation pipelines. The second one is search meta. Search meta we use to get the metadata, or we use to just metadata, not any document. Let's suppose we need to get the result count with the matched, we will use search meta. Let's understand about the relevance score. So relevance score decide the order of the result. MongoDB Atlas Search provide the relevance score with every result. Result with higher score will be on the top of the result list. This relevance score shows how good matched it is. Let's understand some search operators for what we can use with the MongoDB Atlas Search. The first one is the text operator. So to find any text inside the documents, we use text operator. If we want to combine multiple conditions inside our search query, we can use compound operators. The third one is autocomplete. If we want to get any suggestions while we are typing text inside the search bar, we can use autocomplete operator. The fourth one is phase. If we want to search by sequence of words, so we can use, or we need to use, phase operator. The fifth one is wildcard operator. So if we want to get the result with specific words, like I want to perform search for a specific word and want to have result if that text started with specific text or specific prefix, we can use wildcard operator. If we want to filter out my results by any condition like numbers, date, or price, we can use range operator. Let's see about the faceted search. So, so faceted search is used to get the result count with the matched. Please mind on this filter sidebar. These numbers shows how much or how many records are there inside the particular brand or category. This these numbers we retrieved using the faceted search or using the search meta stages. The special things is we don't need to type any text inside the search bar. It comes automatically and update instantly as filters are applied. So let's suppose if you are applying any filters on the price range, instantly it will get updated. Let's see these are in actions. So this is our one collection called sample products. I have prepared this for the demo purpose. So you can see here, we have already seen how we can create the indexes. So I'm using here the dynamic index, okay, and looking for the battery life. So you can see here, we got the result here. Now I want to get the relevance score as well. So inside using the project stage, I can specify the field for which I want to get the relevance score. So you can see here, MongoDB Atlas result score with every result. And the result which higher score will be on the top of the list. So you can see here the result with the higher score on the first positions. Let's see how MongoDB Atlas handle the typos or tolerate the typos. So you can see here, we have some records like ultra phone. Okay. So let me make it sub typos. Look at here. So we didn't get any result because we have records with ultra phone, but I made it ultra phone, right? So let me uncomment this. Okay, you can see here. So we have used fuzzy operator to make the Atlas search to tolerate the typos. This says you need to tolerate the typos for 2 characters. So whether I will type phone or phone, I will get the result. Let's see how we can get the suggestions using autocomplete operator. So for auto get the suggestions, we need to have some changes in at search index sites as well and in our query side as well. So here we have created the search index for to get the suggestions using autocomplete. You can see here we have specified the name on which the field what I want to make the searchable and the type autocomplete. Once I will use this index with my search query, instead of text, I need to use autocomplete inside my query. So you can see here, you would have seen earlier we had to type entire word to get the result, but here we can just type and it will provide the suggestions. So this is how autocomplete works. Let's see how we can use the compound in our query. So if we want to combine multiple conditions while performing the search, we can use compound operator, and inside the compound operator, we have used filter operator. Inside the filter, we have provided two conditions. First, find the text laptop inside the category column, and the range should be the range means the price should be between 900 to $1,500. So you can see here, using the compound operator, I have combined two conditions, and based on that we are getting the result. You can see here, category laptop fall into the given price range. So that is how compound operator works to combine the multiple conditions. Let's see how faceted search works. So as I have already explained, to get the result counts with the match document, we can use faceted search, and for that we need to use search meta stage, not the search. So here I have used the faceted use the index, and inside the facet, so we need to use the facet operator here and add the condition. So I want to apply the conditions, like I want to find the documents where description contains battery, and then combine the matched documents or group the matched documents in group documents by brand. So you can see here we get the faceted counts by brands. So you can see Ksolves has 3 counts, Nova has 2, and Zentek has 2. It shows 3 records exist inside this brand, 2 records inside the Nova, and 2 records inside the Zentek. So this is how we can use the faceted search to get the result counts. So let's see the best practices to remember. So the first thing is use static mapping. In production, only index fields you search or filter on. Keep analyzers consistent. Use filters for non-scoring conditions, because filters skip the ranking math, so they are faster when relevance does not matter. Watch build index build time on large collection. Monitor with Atlas built-in tools. So MongoDB Atlas provides some tools to monitor our indexes or query performance. So that's all we had for today. Once again, thanks for joining.